Hi everyone, David here from Protocol Labs. Today I want to give you a preview of the new IPFS DAG API. The DAG API enables you to create, store, retrieve, and even resolve through any numerical graph, as long as there is an adapter for it. Some examples of numerical graphs are Git, Bitcoin, Ethereum, any blockchain really, torrent files, and of course, the numerical DAG in IPFS and IPLD. Building an adapter to add support to another numerical graph is quite easy. All you have to do is follow the interface IPLD format and implement the operations defined on its spec. As soon as you have built this module, you are good to go, and your numerical graph is now supported. With this, you get a canonical way to manipulate numerical graphs through IPFS. And more, you can leverage the discovery properties of IPFS to find where the data for your graph is located and transfer it through the network, so that the only thing you have to worry is really using the data and nothing else. You can find the API definition on the interface IPFS core spec. As you can see, it is really simple. It offers you primitives for put, for get, for tree, so that you can understand how the graph is built. But instead, let's dive into some examples. I prepared 6 examples to share with you. And don't worry, the code will be available on the GS IPFS repo so that you can just copy-paste it directly. You don't have to stop the video to write it down. The first example is creating a node and storing it through IPFS, through the DAG API. There is this simple function I created here. I would just like to spawn an IPFS node. It is really simple. So it essentially just like creates an instance of the node and does the init process and the load and like takes the node online. And that's all it is doing, really. To create a node and like store it through the DAG API, all I have to do is just like create a standard JSON object and then call IPFS DAG put with that JSON object and tell IPFS which format I'm really using. In this case, I want to use DAG CBOR. This means that this object will be serialized to CBOR, a binary packed format, when it is written to disk or passed through the wire. I'm also specifying here that I want to use the SHA-256 hashing algorithm, but I could use anything really. Like all you have to do is just like pick your own hashing algorithm, and if it is not supported in IPFS today, you can add support to it really easy as well. Once the node is stored on IPFS, I get back a thing called the CID, the content identifier. The content identifier is an extension to the hash, the content address of a given node within the IPFS network. It tells us not only the hash of that node, but also the type of, like the format of that node. We can print it to a human, we can print it into a base encoded string so that it is easy to copy paste everywhere. By default, it encodes to base 58, but you can pick any other encoding by passing as an argument. For example, base 16 or base 32 or whatever, you name it. If I run this file, it's going to store that node and give me back, again, the CID, as expected. Okay, now that we know how to store it, let's see how to retrieve it. Second example is get. So same thing, storing node. All I have to do is do a dag.get to the CID that I received before, and I will get back an object called result, and this object will have a property called value, and this value will be the object I stored. So again, if I run it, I get back the object I had stored. Alright, so now it starts getting interesting. What if I don't want the whole object, but just a part of it? If I'm only interested in part of the data? The third example is exactly that. So same dance, we store the object, but this time we are only interested on one property. We call this the path. We are basically saying through a path that we only want something within this tree, within this object. Here I'm selecting the property name. Here I'm selecting the property likes, but I can even go further and say within the property likes, I know it's an array and I want the first element of that array. So let's run this script. And exactly as expected, I got the name, I got the array, and then I got the first element. I promised you an API that could handle several types of Merkle graphs. But what about traversing through several Merkle graphs at the same time? This is what this example is about. So in this example, I'm creating two nodes. This time, one of the format DAG above, and the other one of the format DAG CBOR. But in the DAG CBOR one, I'm pointing to the DAG above one using the CID. And when I do this, I get the ability to then query for a path within the node, the CBOR node, that has a link to the above node on the hobbies property on the first position. And then I say I want some field of the other node. Let's try this out. Aha, it worked. So what happened here is that I found the node, the CBOR node, and then I traversed through till the maximum I could reach, which was this link. And the IPFS realized, oh, this is a link to another node, so I will fetch that node and continue resolving through. When it fetched that other node, it tried to fetch the remaining of the path that was still to resolve on that node, and it found the data that I had stored there. Cool, huh? One cool utility on the DAG API is the tree command. The tree command enables you to go through the nodes, go through the graph, and list all the paths that are available on that graph. So here I go the same process, create two nodes, just to create an interesting graph, the same nodes that you've seen in the previous example, and instead of like calling get, I call tree, and I say recursive through. This recursive through means I want you to go through and resolve through all of the links that are present on these nodes and retrieve me all of the paths. Let's see what it does when I run this example. Here you go. So it's telling me that on this graph there is all of these paths available that I can resolve and get values from it. It is super useful when you have large graphs or you are just not sure of how the graph is represented, how the graph is organized. And with this way, you get like a very clear way to pick inside and know what you can retrieve from it. Okay, last example, but definitely not the least. I want to show you now the support for resolving through the Ethereum blockchain in JS IPFS. Consider this being like the preview of the preview. There might be still some bugs that we still need to test and prune out before the release. So here, again, jumping, this example is a little bit different. Instead of me creating the nodes, I just like store the blocks directly. I had some blocks from the Ethereum blockchain here on my disk, and I'm using the IPFS block put function to store them into my IPFS node directly. Once they are stored, I can start resolving through them. I have two dag.get calls here, and they are doing a dag.get call on the block blocks that are next to each other. And on the first dag.get, I check for the number, and the second one, I check for its parent's number, so it should be the same. Let's check it out. Voila, that's it. So on the first number, we basically just like fetched one block and got the number from that block. On the second number, which is the same, it is because we basically traversed back in the blockchain and fetched the previous block, which is exactly the number 16, and also printed the number from that block. Isn't this cool? I hope you enjoyed this preview. Some of the things that you have seen here will be released with the version 0.23 of JS IPFS. Keep in mind that it is all alpha, and we are really looking forward to hear from everyone, getting a lot of feedback to make sure that the APIs are useful for everyone and that we prune out all of the pain points before we solidify these APIs. Today, in JS IPFS, we have support for DAG above, DAG CBOR, and Ethereum, and I'm currently working towards getting torrent supported as well. The Go implementation of IPFS has support for also Zcash and Bitcoin in a developer branch. Be sure to keep posted to the developments there as well. Thank you for your time. Chat soon.